section that we're going to cover is about deferred annuities, which is planned savings, where you set money aside every month or every year in an effort to reach, retirement. So this section is no longer in our textbook, the current version. It used to be in the textbook in a previous edition. So in your packet, I scanned the pages from a previous edition so you can read in your packet what used to be in the text. So I'm just going to jump to the lesson here. Oops, there it is. All right, so in this section, we're going to explore annuities, including, we talked about saving for cars and houses. We talked about borrowing for cars and houses. Today, we're going to talk about saving for cars and houses and retirement. So let's say Jen is saving up for a car. She's going to put $200 a month in an account that pays 6% interest compounded monthly. Here are two questions. One's easy and one's hard. How much will she have invested after 3 years if she puts $200 a month into an account? How much has she set aside? She's putting in $200 a month, not a year. For 3 years. $6,000, yeah. You say $200 a month times 12 months in a year. That's how much she would invest in a year, times 3 years, and that will give you $7,200. Okay, so that one's easy. That's how much money she has managed to put aside towards her savings for this car. But the question is actually a little more complicated than that, because her money actually earns interest as it sits in the bank, waiting for her to use it to buy the car, right? But you can't say $7,200 earning 6% interest for 3 years, because all $7,200 wasn't in there to begin with. It earns just a little bit of it at a time, earns 6% interest. So how much will she have in 3 years? This is the hard question that we're going to learn how to answer today. All right, so from your book, a fixed annuity is a sequence of equal payments made or received over regular intervals, monthly, quarterly, or annually, usually monthly. You may be making regular deposits to save for a car or a vacation or a wedding or college, or you may be making regular payments on a car loan or a home mortgage. We talked about that last class. We are going to be talking about making deposits to save today. You could also be at the receiving end of annuity getting regular payments if you from an inheritance or a lottery jackpot. All right, so here's the formula for fixed annuities. The future value of a fixed deferred annuity, where you're going to get T payments or make T payments, each one being P dollars, and have P dollars is your monthly payment. Yep, that's a capital T, yeah. So T is your number of payments, P is the amount of each payment, and little p is your periodic interest rate, right? So that would be like your monthly interest rate. All right, so usually P is R divided by 12 if you make monthly payments. But more generally, P is your APR divided by the number of payments per year. All right, so now we can tackle this question about Jen and her car. Okay, so Jen invests $200 a month in an account paying 6% annual interest compounded monthly. How much will she have in 3 years? So we're going to use this formula. F is what we're looking for, right? P, capital P, is $200. Those are her monthly payments into this account. Her periodic interest rate, lowercase p, is her APR of 0.06 divided by 12, because this is happening monthly. And capital T is the number of total payments. So she's putting in monthly payments for 3 years. How many payments is that? 36. 12 months times 3 years is 36 payments. Maybe I'll write down how I got that. All right, so does that make sense so far? So all I'm trying to do is take the information from the question and assign each piece of information to one of the variables. All right, so now I'm going to plug into this formula. Future value is what I don't know. So I'm going to have $200 times, all right, 1 plus little p. Let's calculate what little p is. Yeah. 0.06 divided by 12 is 0.005. Okay, so next I have 1 plus 0.005 raised to the t, which is 36, minus 1 over 0.005. All right, so this is just an ugly arithmetic problem. You just have to know how to do the order of operations. And you should probably not round anything until the very end, because we want to be really accurate in figuring out how much money is going to be in this account. All right, so I have a big square set of parentheses, so I have to work inside that first, right? And within the square brackets, I have a smaller set of parentheses. So I'm going to do that first. 1 plus 0.005. 1.005. Okay. Then the next thing I should do in the order of operations is exponents, right? Parentheses, exponents. So I'm going to raise that to the 36th power. Subtract 1. Divide by 0.005. And then times 200. So this account is going to have $7,867.22 in it. Does that amount make sense? Is that a reasonable amount based on how much she put into that account? Yeah, she put a total of $7,200 in. It makes sense that this would be slightly bigger than that because her money was earning interest. Okay, so Jen has her heart set on a car that costs $10,000. How much more would she need to invest each month so that she could afford this car? Right? So now we're being told what we want the future value to be, and we're trying to figure out how much to invest. So all the other stuff is staying the same. So if I write down my formula, it's going to be P times 1 plus P to the T, 1 plus P to the T minus 1 over P. Right. Okay. So now I'm going to put in the stuff I know. This time I want to know what capital P should be to make F 10,000. Okay, so I'm going to go over here and I'm going to put in a 10,000 for F. That's how much I want in there, my future value. P I don't know. That's what I'm trying to figure out. And then the rest of this stays the same. Little p is still 0.005. So I'm going to have 1.005 to the 36 minus 1 over 0.005. So I just have to simplify all that stuff that's in the square brackets. That's just some number. So this says P times some number equals 10,000. I just have to divide both sides by whatever that number is. Yes, question. Okay, what do you got? Mm-hmm. Mm-hmm. $2,200, yeah. Yeah. The percent rate is still 6%. Oh. So you could do a similar thing to what I'm doing right here, but instead of using a 10,000, use a 2,200, and that would give you the additional amount she needs to put aside instead of the total amount. So you could do what you're explaining. If you put a 2,200 there, the number you're going to come up with is how much over 200 she needs to invest. Right? And if I use 10,000, I'll get the total amount. All right, so let's see, 1.005 to the 36 minus 1 divided by 0.005, and I get like 39.336. So 10,000 equals P times 39.336 with a bunch more decimals that are important. I'm not writing them down because I'm gonna have them in my calculator, right? I don't need to write every single one down. I just write it down to sort of keep track of my work. So my next step is to divide both sides of that equation by 10,000. I'm sorry, divide both sides of the equation by 39.336. So I'm going to do 10,000 divided by, I need that number. On this calculator, I can call up my previous answer by doing second answer. It's the negative sign. Other calculators have other ways. I can come around and help you figure out your own calculator. I do second answer, and it calls up my previous answer. You could also have stored that number or written down every decimal. So this comes out to $254.22. I rounded it up because if we round it down, she won't quite have $10,000. You round it up, she might have 10,000 and just, you know, a few pennies or something. So if we had done what you were suggesting, Emma, and put a 2,200 here, we should have come out with 54.22 as our answer. Additional amount over 10,000. All right, so everybody okay with this so far? All right. So Sandy has won the lottery. Congratulations. Yeah. She has two options for how she can receive her winnings. You could take one lump sum of $500,000 today, or she could get one check for $10,000 every 3 months for the next 20 years. Assuming that Sandy could invest her money in an account that pays 5% interest compounded monthly, which option should she choose? All right, so let's say if she gets $500,000 today and invests it, we'll see how much she has later. So from several classes ago, the compound interest formula was that guy. That's your compound interest formula. I know, there's a lot of formulas. You do not have to memorize all these formulas. If you remember, the beginning of this packet has all of these formulas written in it, along with what they are, right? So what's hard, I know, is knowing when to use which formula. It takes practice. We'll work on that. Okay. All right, but yes, you can use that paper for your test, yes. Okay, so $500,000 put in an account where I earn interest that's compounded monthly is this formula, okay? And monthly means 12 times per year, so my N is 12. My principal is $500,000. My interest rate was 5%, 0.05, divided by 12 to the 12 times, T is time, right? In years, so that is 20 in this case. Now, just very carefully follow the order of operations, and we can figure out how much this account is worth in 20 years. So, do what's in the parentheses first. And within the parentheses, you should do the division first. So I start with 0.05 divided by 12, and I get 0.0041666666. All right, so next, within that set of parentheses, I would add 1 plus 1. Then I would raise it to that exponent, right? Because the next thing in the order of operations after parentheses is exponents. So raise that to, what's 12 times 20? 240? You raise that to the 240th power. And then you multiply by 500,000. And we have $1,356,320.14. All right, so that's option 1. lump sum payment in 20 years will be worth $1,356,000. Okay. What happens in option 2? Okay. Option 2, she's going to get a $10,000 payment every 3 months for the next 20 years. And every time she gets a check, we're going to assume she just puts it right in the bank into an account earning 5% interest. What's the matter, April? Okay. All right, so this is our new formula, right? Because she's making regular deposits. It's not just one lump sum that you throw in the bank and let it grow, right? Our new formula, you make payments. So if I write down that formula, right, it was F is equal to P times a big square bracket, and then you have 1 plus little p to the t minus 1 over little p. All right, so capital P here is the payments, $10,000. She's going to put $10,000 in the bank every 3 months. Okay. All right, so what's little p here, right? Little p is called the periodic interest rate. It's your APR, which is 0.05. Usually it's divided by 12 because that's how many payments you make a year. But how many payments is Sandy making a year? 4. Yeah, because she's putting $10,000 into the bank every 3 months, not every month. So it's 4 payments per year. So that is the denominator for the periodic interest rate, right? We'd call that a quarterly interest rate. So 0.05 divided by 4, 0.0125. All right, so I can 1.0125 raised to the t, which is the number of payments. How many times is she going to get that $10,000 check? 80, yeah. She's getting one 4 times a year for 20 years. That's 80 total payments. All right, so we just try to follow the order of operations. 1.0125 raised to the 80th, then minus 1, then divided by 0.0125 times 10,000. $1,361,187.95. All right, so which option should she choose? Option 2. Option 2 is a little bit more. It's not that much better. In both of them, you have to have the discipline to put the money in the bank and not touch it for 20 years, right? I know, yeah. Okay, so this is all kind of building up to how we save for retirement. So Ian and Caitlin decide to begin saving for their retirements. We love teaching at GCC, but we don't want to work forever. So we're each going to open up a Roth IRA. It's a wonderful investment vehicle. You're allowed to invest up to $5,000 per year. That number fluctuates based on what Congress says every year. But when I wrote this, it was $5,000 per year. And you don't have to pay taxes on the gains that your money makes when you take it out at retirement age. Okay, so most investment vehicles, when you take your money out, however much money you made through that investment, you have to pay taxes on. But this is a special one where you don't have to. The downside is that once you put money into a Roth IRA, your money is basically locked up until you reach retirement age. If you want to use that money before you're in your 60s, you pay steep penalties, though there are exceptions. First-time home buyer, medical bills. If you end up with medical bills, you can use your IRA without penalty. Yeah. All right, so assume that IRAs can earn 7% interest per year, and that's not crazy. This because an IRA is usually some kind of mutual fund, invest in stocks and bonds, and 7%. It's not like a bank where they pay you almost nothing, right? Okay, so on Ian's 31st birthday, he puts $2,000, 34th birthday, he puts $2,000 into an IRA. On each of his 9 subsequent birthdays, he makes another $2,000 deposit, but then he stops adding money to the account. So he's going to invest for 10 straight years, $2,000 a year. Okay? And then Caitlin, me, I'm following a similar investment plan, but I started saving for retirement when I was 22. Right. Yeah. On my 22nd birthday, I deposited $1,000, so only half of what Ian's putting in per year. I'm putting in 1,000, and like Ian, I make a total of 10 equal annual deposits and then stop adding money to the account. So I'm putting $10,000 deposits into this IRA. Ian's putting 10 $2,000 deposits. So he's investing $20,000 total. I'm investing $10,000 total towards retirement. All right, so the question is, how much money will each person have in their IRA when they retire on their 64th birthday? So it's a tough question. If we both made investments all the way up until we retire, then we'd be involved in an annuity that use that formula that we just learned today. But since we stopped investing, but that we continued to let the money grow, we have to answer this question in 2 steps. One, we figure out how much money we have after the last deposit, after the 10th deposit. Then pretend that you make 1 deposit into a new account after the 10 years of investing, and we'll figure out what that account grows to using our compounding formula from 2 classes ago. All right, so here's Ian's scenario one more time. 34th birthday, he puts $2,000 into an IRA. Each of his 9 subsequent birthdays, he makes another $2,000 deposit, but then he stops adding money to the account. All right, so we're going to assume that the IRA earns 7% interest per year, compounded annually. How much money will there be in the account the moment after he makes the last $2,000 deposit? Well, that is this formula we've been using all class. Future value is your payment amount times 1 plus little p to the t minus 1 over little p. Ian's payment amounts are $2,000. And we've got 1 plus little p. We have a 7% APR. And how many payments is Ian making a year? Each year, 1. Yeah. So little p is 0.07 divided by 1, because there's only 1 payment per year, so it's just 0.07. And capital T is 10, that's what's 10, right? 10 total payments. And then we're going to do minus 1 over little p, and we'll see how much this is. Okay, so 1.07 raised to the 10th, then minus 1, then divide by 0.07, then times $2,000. And we get 27,000. Where did that happen? 27,632.89. No, because this is a situation where you're putting your money, you're lending your money to somebody, and they're paying you interest. They're not going to pay you anything extra than what they owe you. All right, so that seems reasonable because he put $20,000 into this account, right? $2,000 10 times. That's a total of a $20,000 investment. So he made a little more than $7,000 in interest. It's a reasonable result with a 7% interest rate. All right, so now we have to do the second part. So now he's done investing. He's done putting money into this account. Now we're just going to let this grow until he retires. So the formula for money that you just plunk into account and let it grow for a certain amount of time, that is your P times 1 plus R over N to the NT. That's money that you just plop in there and watch it grow. So his P, his principal, his initial investment is the $27,000. That's how much he has now. All right, and my interest rate's 0.07. It says that this is being compounded annually, which means 1 time per year. So that's over 1. And we're going to do this for how long? How long until Ian retires? 20? Maybe. Let's just count on our fingers just to be safe, because this kind of thing like always throws me off. So he puts money in on his 34th birthday, right? And he's going to make 10 total payments. So we have 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. He's 43 when he makes the last investment. How many years from 43 until the 64th birthday? 21? 21. Yeah. So 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64. 21 years. 21 more years times 1 times per year. Okay. That is a great question. There are all kinds of exceptions and extenuating circumstances, and like a tax professional or a financial advisor would know all the answers. I don't. but that, I mean, there are lots of if then you can use your retirement money, but I don't know the exact answers. All right, so 0.07 divided by 1 is just 0.07. So I've got 1.07 raised to the 21, and then I have to multiply that by 27,632.89, and we get $114,415.70. So a $20,000 investment over the course of 31 years grows into $114,415.70. So that's how much Ian has when he retires. I would like you guys to try to go through this process that we just did for Ian for me, right? Figure out how much I'm going to have when I retire. So again, 2 steps. First, use the future value when you have regular payments. Then just take that amount and let it grow until I retire. Okay, so let's go over the details together. How much money will Caitlin have at retirement? Okay, so the first part is going to look just like Ian's first calculation, because we're investing in the same fund or whatever, getting 7% interest. But I'm investing $1,000 instead of $2,000. So just replace that 2,000 with a 1,000. So we have 1,000 times 1.07 to the 10 minus 1 over 0.07. And that comes out to, anybody have it? Okay, so at the end of my 10 years of investing, I have $13,816.44, which is less than half of what Ian has, right? So that makes sense. He invested 20,000, I invested 10,000. I didn't make as much, right? But that's just step 1, right? Step 2 is you take that money and you let it grow until you retire. Right? So future value of that money is based on this formula, where n is the number of compoundings per year, and because this is compounded annually, it's a 1. And P is my 13,816.44. times 1 plus 0.07 over 1. Now, how many years is this going to grow for? 33 years. So I invested from my 22nd to my 31st birthday. That's 10 total investments. And then the time from 31 to 64 is 33 years. No, it's 33.
No, I meant technically 32nd. You already invested.
Right. Oh, yes. So yeah, it's like you're counting, like when you count along a number line. Right? I'm not actually counting birthdays, I'm counting years. So I would say when I hit 32, that's 1, right? So that's 1 year has gone by. So you would start counting at 32 and you go 32, 33, 34, 35. Use your fingers like that. So it's a total of 33 years. And that comes out to 128,000, what's the rest? 843.09. Oh. You're not going to count all this stuff like that. No, I won't. No. No, small rounding errors that result in penny differences are not a big deal. But this, I mean, but banks, investment, financial things are typically very precise, right? You don't want to have your financial institution be like, that's rounding. What are you going to do? You know? So I end up with $128,842.99 compared to Ian's $114,415.70. Why do I have so much more? I started investing earlier. I invested half as much, but because it had longer to grow, I ended up with more money. So the moral of the story is invest right now, right? The sooner you do it, the better. It's not too late. Okay, so to summarize, how much did Ian invest in total? $20,000. He put $2,000 in for 10 years, right? At retirement, he had 114,000 something. 114, 415.70. And then Caitlin, she invested only $10,000, but at retirement had 128,000. 842.99. Okay. So this seems to illustrate a contradiction. I invested less, but I got more money. And the moral of the example is, yeah, invest now. Yeah. Right? The longer you have, the better your investment will pay off. No.